Hello, Sycamore. Did you paint a rainbow? I did. This is mine. Now, I'd like to talk to you about the science of rainbows. So I've switched to a different camera, which means you're not going to see my face. But it should mean I can be in focus when we look at this page. Rainbows. Now, you might know some things about rainbows already. You might know to get a rainbow, we need the sun and the rain. But I think there's some more things we need to know. Number one, the sun up in the sky gives out light in all the colours that we can see. It also gives out light in some colours we can't see. And that light just looks white to us because it's all the colours mixed together. And bees, who are really, really cool, they've got different things in their eyes. They can see colours we can't. So that when they look at flowers, they can see secret markings we can't see. Now, number two, light is made up of electromagnetic waves. Electromagnetic waves are a little bit wiggly. Red light's wiggle is about 665 nanometers long. Violet's is about 400 nanometers. The proper name for how long a wiggle is its wavelength, which scientists represent with a lambda, which is that little thing there. Now, red light's lambda is 665 nanometers. Now, over here, if we have a look, it says 1 millimeter is 1,000,000 nanometers long. So a nanometer is teeny, tiny, teeny, tiny. Now, an X-ray is another kind of electromagnetic wave, like light, and it's very small. And radios use really, really long ones. So more things than you think are part of the same sort of stuff as light. It's just that we can't see them. When light goes through something new, like a raindrop, it refracts. Now, refracting is a bit like bending. It changes direction. Red changes at 42 degrees. Now, we know that 90 degrees would be a right angle, so it's about just under half a right angle. And blue-violet light changes at about 40 degrees. When I'm thinking about this, it's not quite right, but I like to think about a little red lorry taking a long time to turn a corner, and a little purple car being able to turn that corner just a little bit quicker because it's smaller. Now, to get a rainbow, we do need that sun to be behind us. And we need to be there. We won't get a rainbow if there's not eyes looking at the rainbow. All the drops coming out of my rain cloud reflect all the colours. But your eyes are in the right place to only see one colour from each little raindrop. Your eyes are kind of catching the little bits of light from different heights. So up at the top, where they're bending further, you'll see the red. A little bit further down, you'll see the yellow and the orange, and then the green, then the blue, then the indigo and the violet. You only see one colour from each drop, but all the other colours are there. They're just not going in the right direction for you to see them. Now, rainbows are actually circles. They're centred around you. You're right at the middle, and the circle goes all the way around you. But normally the ground or trees or buildings get in the way. Skydivers and other people who go up really high, so maybe like pilots, can sometimes see the whole circle of the rainbow, which I think is really, really neat. Right. And that's my information on rainbows. I used a couple of things to help me make sure I wasn't missing out any of the really cool facts on rainbows. I used this book, which is fast becoming one of my favourite books. It's called The Thing Explainer by someone called Randall Monroe. I also used a SciShow video about how rainbows are made. You might want to go and find those yourselves and have a watch too. All right, Sycamore, take care. If you haven't drawn a rainbow, you might want to think about doing so. Have a good afternoon. Bye.